Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video we're going to create a game of Snake using JavaScript, so sit back, relax, and enjoy the show. Hey, what is up everybody? In this video we're going to create a game of Snake. Let's head to our HTML file. I'll create a div as a container. Div ID equals game container. Let's close it. We'll be using a canvas to draw our components. Canvas, the ID will be game board. I'm going to go ahead and set the width and the height attributes right away. 500 for the width. The height will be 500 as well. Then close the canvas. I'll add a score. Div ID equals score. Let's close the div section. The initial score will be set to 0. Then we'll need a reset button. Button, close it. ID equals reset button. The text is reset. Okay, let's work on our CSS styling. That's everything for our HTML file. Let's select our game board. Game board. This is an ID. I'll add a border. Border 3 pixels solid is good. Let's center everything within our game container. Game container. Text, align, center. I'll change the font of the score. You can barely see it. Score. Font. Family. Pick whatever font you like. One font that I like is Permanent Marker. Permanent marker, then a backup of cursive. Let's change the font size 100 pixels. Then let's work on our button next. Reset button. I'll pick the same font family. The font size will be 22 pixels. A width of 100 pixels. A height of 50 pixels. Border 4 pixels solid. Border radius to round the corners 15 pixels. Then cursor pointer when we hover our cursor over this button. Okay, that is our CSS style sheet and our index.html file. Let's head to our JavaScript file. We have a lot of variables to declare. Let's begin with the constants. Const gameboard equals document dot query selector. We are selecting an ID. That ID is gameboard. That's our canvas. With a canvas, to paint on the canvas, we have to get the context. Const ctx for context equals gameboard dot get context, then pass in 2D. We'll store our score text as a variable. Const score text equals document dot query selector. We're selecting an ID. The ID is score. Let's change this ID to score text. We're already going to have a score variable. Hey, this is Future Bro. So I forgot to change that within my CSS style sheet. Make sure you make that change here as well. Let's select our reset button. Const reset button equals document dot query selector. We are selecting our reset button. I'm going to create a variable to hold the width of our game board. Const game width equals gameboard dot width, then game height. Const game height equals gameboard dot height. Width and height are the attributes that we assigned within our canvas. Initially, when we run this JavaScript file, if we would have declared those within the CSS file, they wouldn't have been available to us right away. That's why I assigned these attributes within the element itself inline. We're going to assign some colors. The first is for the board background. Const board background equals pick a color. I'll just pick white. Pick a color for your snake. Const snake color. I'll pick light green. But feel free to pick a different color. I'll add a black border around the snake. Snake border equals black. Then we'll need some color for the food. Const food color equals red. It's an apple. Okay, then a unit size. What's the size of everything within our game? Const unit size equals, I'll pick 25 pixels. Now we'll create a couple more variables. Let running equal false. We'll examine running to see if our game is currently running or not. Let x velocity. X velocity will be how far we move on the x-axis every single game tick. I will set this to be the unit size. We'll be moving 25 pixels on the x-axis every game tick. If x velocity is a positive number, we'll move to the right. If it's negative, we'll move to the left. Then we have y velocity. Let y velocity equal 0. That means we're not moving up or down. If we would like to move down, we would set this to unit size. If we would like to move up, we would set that to negative unit size to move up or down one space, 1 unit. But to begin, we'll just be moving to the right. We'll need the coordinates of our food. Let food x coordinate. Let food y. We'll calculate these randomly later within a function. Let score equals 0. Then we need our snake. Our snake is going to be an array of objects, an array of parts. Let snake equal straight brackets, it's an array, and we will create objects, an object for each body part. Each body part will have an x and a y coordinate. Let's begin with the tail. The tail will begin in the top left corner, so I will set those coordinates. 0, 0 is the top left corner. Initially, let's create 5 body parts to the snake, but after it eats its food, it's going to increase by 1. Let's add a second body part. This is a separate object, separated with a comma, but I don't want this in the same space. I'll place this next body part to the right of the first one. So let's say x is unit size times 1, or just unit size, I suppose. Okay, let's add another body part. Unit size times 2. So we'll have 3 squares. Okay, 2 more body parts. Unit size times 3. Unit size times 4. And that's our snake. It's an array of objects, body parts. Each object is a body part of the snake. They each have their own x and y coordinates. Let's add an event listener to our window to listen for key events. Window.add event listener. The event is key down. We'll pass in a callback to a change direction function. Then we'll add an event listener to our reset button to restart the game. Reset button dot add event listener. When we click, we will invoke the reset game function, which we still need to declare. Then we will invoke game start. Let's declare the functions that we'll need. Let's begin with the first. Function game start. Function next tick. Function clear board. Clear board is going to be in charge of repainting the board. Function create food. The create food function will find a random place within our game board to place a food item. Function draw food. We'll need to paint the food within our game board. Function move snake. Function draw snake. Function change direction. Function check game over. function display game over. Then lastly, function reset game. Those are the functions. Let's begin with the create food function. We'll create an inner function. Function random food. There will be two parameters, min, then max. Within this function, we'll return a random number. Return rand number. So to calculate this number, we'll store this within const rand num. Set this equal to math.round math.random. We will multiply this by max minus min, plus the minimum if there is one. I think I'm going to expand this. All right, just to demonstrate this, I'm going to invoke the random food function and store this within food x. Food x equals random food. We'll pass the minimum, 0, then the max, game width minus our unit size. Temporarily, I'm just going to display whatever food x is. I have to explain something. Then we will invoke this create food function temporarily. I gotta explain something. Currently, when we're generating a random number, that random number is between 0, then our game width minus our unit size. Every time I run this, I have a random number between that range. However, I would like to divide the width and the height of my game into spaces. I will take this part of this expression divided by unit size. Now we'll receive a random space between 0 and 24 because 500 divided by 25, our unit size, is 25 available spaces. To accurately place the food in the top left corner of one of these spaces, I will multiply all of this by unit size. So every time I refresh this, you can see that all of these numbers are divisible by 25. And that's what we're looking for. Let's create food y. Food y equals the same thing. Okay, that is our create food function. Let's move on to the draw food function. This is fairly easy. We'll take our context, set the fill style equal to our food color. Take our context, fill rect to fill a rectangle. We need a pair of coordinates. Food x, food y. We need a width and a height. They are both going to be unit size. Now, if I were to invoke the draw food function after the create food function, this will draw a random food item every time we refresh the page. And that's what we're looking for. That completes the create food function and the draw food function. I'm going to eliminate these two function calls. We're going to fill in the game start function. We will set running equal to true. Our game is currently running. We'll update the score text content to equal whatever our score is. Initially, it's going to be 0. We'll invoke the create food function, then the draw food function. Then lastly, next tick. Next tick is what we want to do every round, every time we update the clock. Okay, every time I refresh this, an apple should appear randomly within your game board. Let's close the game start function. We'll work on the next tick function. We'll check to see if our game is currently running. If running, let's invoke the set timeout method. Set timeout, we'll use an arrow function expression. There's a lot we have to do. We'll list an order of steps. First, we'll clear the board. Clear board function, followed by draw food, move snake, draw snake, check game over, then invoke next tick again. So after the right curly brace, how often do we want a game tick to occur? Maybe 75 milliseconds, that's a good speed. If you would like a slower speed, you can increase the number or decrease the number for a faster speed. I'll just pick 75. Then we'll add an else statement. Else display game over. If our game currently isn't running, that means the game's over. So that is the next tick function. Let's work on clear board. This is fairly simple. We'll take our context, set the fill style. We'll take our fill style, set this equal to board background. This is a color that we picked. Take our context, fill rect. We'll begin in the top left corner, 0, 0. We'll end in the bottom right corner. We will take our game width for the width, game height for the height. And that's it for this function. Let's work on draw snake. We'll need to change the fill style. Context dot fill style equals snake color. For my snake, I picked green. If you have a border, we can set the stroke style. Context dot stroke style equals snake border. We'll take our snake. It's an array of objects, so there is a for each method. I'll use an arrow function expression. The argument is snake part. For every snake part, then within curly braces, I will take our context, fill rectangle, snake part. Each snake part has an X coordinate and a Y coordinate. So we'll begin painting wherever that snake part currently is, on the X axis and the Y axis. What's the width and the height of the snake part? Well, our unit size, 25 pixels. And the height is 25 as well, unit size. Hey, if you have a border, we can fill that in. Let's copy this, paste it. Stroke rect. Looks like I misspelled something. Clear board fill rect, not rext. Okay, and that will draw our snake. So now how do we move our snake? Let's go to the move snake function. To move the snake, we're going to create a new head of the snake in the direction that we're moving, then eliminate the tail. Const head equals, then within curly braces, the X coordinate will be our snake's current head. So that has an index of 0. Take the X coordinate of that, plus our X velocity. How far are we moving on the X axis? This will be a positive number if we're going right, a negative number if we're going left. Okay, then do the same thing with Y. Y equals snake at index of 0 dot Y plus the Y velocity. Then to add this new head to our snake, we can use the unshift method. Snake dot unshift head. Okay, so our snake is just expanding. Now we need to eliminate the tail after each move. I'll use an if-else statement. If else will be snake.pop. That will eliminate the tail every time that we move. But I gotta fill in something for now. I'm just going to set this to be false. Just temporarily. Okay, our snake should move now. Within this if statement, we'll check to see if the food was eaten. If food is eaten. So that's a comment. If the head of our snake, snake at index 0, take the X coordinate, we will use the comparison operator. Is the X coordinate of our snake equal to the X coordinate of our food? Food X. And let's copy this portion. The Y coordinate of the head of the snake is equal to food Y. If the head of the snake and the food are overlapping, well then the snake has eaten the apple. Let's increment the player score by 1. Score plus equals 1. Change the score text. Score text dot text content equals the new score. Then create a new food object. Create food. We have no way to test this until we can control our snake. Let's close out of this function. Then go to the change direction function. The change direction function should have one parameter, event. We invoke this function every time we press a key. Our window is currently looking for the key down event. We'll store this within const key pressed. Set this equal to event dot key code. So I'm going to display whatever key pressed is currently with console.log. I'm going to click on my window and press up, down, left, right. Each of those 4 arrow keys has a key number. That's what we're looking for. In fact, I'm going to store those. Let's say const left equals 37. Const right equals 39. Const up equals 38. Const down equals 40. Actually, I'm going to rearrange these so that they're all in numeric order. Much better. This is how to determine which way our snake is headed. I'll store these within some constants. Const going up equals, we'll write a condition, is the y velocity of our snake equal to negative unit size. So our unit size is currently 25. If the y velocity of the snake is negative 25, that means we're moving up. So let's do the same with the other directions. Going up, going down, going right, going left. Going down is going to be y velocity is equal to unit size, positive. Then x velocity is equal to positive unit size. Going left is x velocity is equal to negative unit size. So these will be Boolean variables. I'm going to write a switch. Switch will examine true against many matching cases. The first case will be key pressed is equal to left. And we are not going right. We don't want to be able to move like to the left, then immediately to the right, because according to the rules of Snake, if any body parts touch, then we lose the game. We don't want to accidentally go back into any body parts. So if we're going left, we can continue to go left, otherwise up or down, but not right, because then we lose the game. If we would like to go left, then let's set the x velocity equal to negative unit size. Take our y velocity, set that equal to 0. We're no longer going up or down. Then break. Let's add another case. Key pressed equals up, and we are not going down. X velocity equals 0. Y velocity equals negative unit size. We need another case. Key pressed equals right, and we are not going left. X velocity equals unit size. Y velocity equals 0. Okay, last one. Key pressed equals down, and we are not going up. X velocity equals 0. Y velocity equals unit size. Okay, we should be able to control our snake now. Yeah, there we go. We can go up, left, down, right. So let's eat the apple and we should expand. And our score increases. Now let's work on getting a game over, because we can go off the screen currently, which we should not be able to do. Okay, let's close out of this function. Check game over. If we pass one of these borders, then we have a game over. I'll write a switch to check that. Switch will examine true against many matching cases. The first case will be, is the head of our snake at index 0, take the x coordinate, is that less than 0? That means we went over the left border. If this case evaluates to be true, well, we have a matching case. So let's take running, set this equal to false. Then break. So if I go over the left border, the game stops running. Okay, let's add another case. If the x coordinate of the head of our snake is greater than or equal to the game width. Now if we go over the right border, the game ends. Take the y coordinate of the head of our snake, check to see if it's less than 0. That means we go over the top. Game's over. Then the last one is case y is greater than or equal to game height. We shouldn't be able to go over the bottom border. Yeah, awesome. There is another game over condition too, if any body parts of the snake overlap. To check that, I'm going to use a for loop to iterate over the body parts. For, then our index is going to be I. We don't want to begin at the head. Let I equal 1. That's why I'm not using the for each method. Our condition to continue is I is less than snake dot length property. Increment I by 1. We'll write an if statement. If our snake at index of I, that's going to be one of the body parts besides the head, because we're starting at 1. If the x coordinate of that body part is equal to snake at index of 0, take that x coordinate, and let's copy this, paste it, change x to y. If the head of our snake is equal to one of the body parts, that means the game's over. Running equals false. Okay, let's test that. Yeah, the game just ended. Now we'll want to display game over. Let's close out of the check game over function, then head to display game over. I'll take the context, access the font, set this equal to a font of your choosing. I'll pick 50 pixels, MV Bully, context.fill style. Pick a color, I'll just pick black. I'll center the text, context, text align equals center. To draw some text on a canvas, we'll type context.fill text, add a string of text, game over, then your placement. I'll put this right in the middle. Game width divided by 2, comma, game height divided by 2. Then set running equal to false. Okay, so when we hit a border, it's game over. Then when the head of our snake runs into a body part, it's also game over. The last thing we need to do is set up the reset game function. We'll take our score, set that back to 0, take the x velocity, set that equal to unit size, take our y velocity, set that equal to 0. We'll recreate our snake, copy that, paste it, but we're not going to use the let keyword, then invoke the game start function. So after we get game over, we should be able to reset our game. Yeah, sweet. Well, okay then everybody, that is a game of Snake using JavaScript. If you would like a copy of all this code, I'll post this in the comments section down below. Be sure to check the original playlist. And well, yeah, that's how to create a game of Snake using JavaScript.